Hello students, secondary 2 chemistry. Now we are going to continue in unit 2 modern periodic table of elements. Here are something called ranges in the periodic table of elements. 6 ranges in the periodic table of elements are being studied today or in several lessons. Atomic radius is the first trend. Ionization energy, electron affinity, electronegativity, metallic and non-metallic properties, acidic and basic properties, oxidation number. Now we start with the new trend, which is called atomic radius. If you have two similar atoms and measure the distance between the two nuclei, which are the centers of the two atoms, and divide this distance over 2, you get the radius of the atom. Okay, in the same way here is if two identical atoms, if you measure the distance between the two nuclei of the two atoms and divide this distance over 2, you will get the radius of the atom. If you have two dissimilar atoms and measure the distance between the two nuclei, you get what is known as bond length. You can't divide this distance over 2 to get the radius of any atom because the two atoms are different. Here, for example, two fluorine atoms combine together to form a fluorine molecule. If the distance between the two nuclei, the bond length here is 143 picometer. 1 picometer is equal to 10 to the minus 10 meter. If you divide this distance over 2, you get the radius of fluorine atom, which is approximately 72 picometer. In bromine molecule, for example, if the bond length between the two nuclei is 228 picometer. If you divide this distance over 2, you will get 114 picometer, and so on. So the bond length, the distance between the two nuclei of the two bonded atoms, atomic radius is half the distance between the two centers of the two centers means the two nuclei of the two atoms in a diatomic molecule. This two diatomic molecule means two similar atoms combined together. How this distance is called the atomic radius. If the two atoms are not atom but cation and anion, you get what is known as ionic radius, the distance between the centers of cations and anions in the formula unit. Here, if you want to complete this, 1 angstrom equal to 10 to the minus 10 meter. This here is also 1 angstrom is the answer here. If you want to solve a problem, the bond length in chlorine molecule ClCl is 1.98 angstrom, and the bond length between carbon and chlorine atoms CCl equal to 1.76 angstrom. Calculate the atomic radius of carbon. Here is the chlorine molecule ClCl, distance 1.98 angstrom. If you divide this distance 1.98 over 2, you get the radius of chlorine atom, the radius of one chlorine atom. If you subtract this distance, this radius of the chlorine atom from the bond length here, from the distance from A to B, chlorine and carbon, you get the radius of carbon atom. This is calculate the radius of carbon atom. So the answer is divide this over 2 to get the radius of one chlorine atom, then subtract the radius of one chlorine atom from the bond length here in carbon chlorine bond. You get the radius of carbon atom. This is an example. The atomic radius of different elements in the periodic table. Here, through any period, the atomic radius decreases due to the increase of the charge of the nucleus. As the atomic charge increases, the charge of the nucleus increases, the attraction between the nucleus and the outer electrons increases, so the atoms become smaller and smaller, and the radius decreases gradually from the left to the right. Through the group, the atomic radius increases from the top to the bottom, increases. This is because a new energy level increases. As you move from the top to the bottom, the new energy level increases, so the atomic radius increases. If you remove an electron from an atom, the atomic radius becomes smaller and smaller. This is a neutral atom. This is a sodium ion, which is an atom from which an electron is removed. The atomic radius decreases because the attraction between the nucleus and the rest of the electron increases, so the radius decreases. In the opposite situation here, chlorine atom acquired an electron to become a chloride ion. Chloride ion has one extra electron, so a repulsion occurs between this extra electron and the rest of the existing electrons. This repulsion results in increase in the radius of the anion. So the radius of the cation is smaller than the radius of the neutral atom, while in the case of anions, the radius of the anion is greater than the radius of the neutral atom. Here are examples: lithium atom, lithium ion, smaller; bromine atom, bromine ion, smaller, and so on. Here are anions. This is the fluorine atom, small; fluoride anion, larger, and so on with other anions. The second trend is called ionization energy. Ionization energy is the amount of energy required to move the most loosely bound electron completely from an isolated gaseous atom. If you want to remove an electron from any atom, you must exert energy to overcome the attraction force between the electron and the nucleus. If you want to remove one electron, you must exert the first ionization energy to remove the first electron. So here's ionization energy is the amount of energy required to remove the first electron, or to convert an atom to an ion with one positive charge. This equation represents what happens. This is a neutral atom. This is the ionization energy, the energy required to remove the electron from this neutral atom. After losing the electron, this is the ion. Okay, plus electron. Plus electron. Second ionization energy, the amount of energy required to remove another electron, the second electron, or to convert the first ion to the second ion, M plus to M plus plus. This is energy, second ionization energy, which removes the second electron. This is called second ionization energy, and so on. You can also remove the third electron, the third ionization energy, which is the energy required to convert M plus plus to M plus plus plus. Okay. Ionization energy increases from the left to the right through any period. This is why, because as you move from left to right, the size of the atom decreases, atomic radius decreases, so the attraction between the nucleus and the outer electron increases. So you need more and more energy to overcome this attraction. If you move through any group from the top to the bottom, because as you move from the top to the bottom, the radius increases, so the distance between the nucleus and the outer electrons increases gradually from the top to the bottom. So losing of electrons of the outer electron becomes relatively easier as you move from the top to the bottom, because the distance increases from the nucleus to the outer electrons. So ionization energy decreases here from the top to the bottom through any group, while when moving from the left to the right in any period, atomic radius decreases, so ionization energy increases. Here the atomic radius increases, the ionization energy decreases. That's all we want to say, and thank you for listening.